So, welcome to lesson 9 of your electricity unit of work. Lesson 9 is on domestic uses of electricity and using electricity safely. So, as you'll see, there's some points from the specification just that we are going to try and cover today, and just have a little skim read through those. And then on the next page, if you could focus on the knowledge check questions to begin with, pause the video and just have a go at them and see if you can get them correct as correct as you can, answering true or false for each of those statements. Right, pause the video and have a go at them now. Right, hopefully you've unpaused the video and we can now go through the answers to these. So, a voltmeter was placed in series with the component that is measuring the current across. False. Total resistance in parallel circuits is the same as the smallest separate resistance. False. Remember, it's smaller. An ammeter is placed in parallel with the component that is measuring the current through. Nope, it's false. Remember, ammeters are placed in series, voltmeters in parallel. If a 100 ohms resistor was placed in parallel with a 200 ohms resistor in a circuit, the total resistance would be more than 200 ohms. False, it would be less. An electric current is made up of electrons. False, it's the flow of electrons or charged particles around a circuit. Now, the total resistance of two resistors in parallel is smaller than the resistance of the smallest resistor. True, smaller. Total current in parallel circuits is equal to the sum of each of the separate components. True. Remember, A2 plus A3 equals A1 equals A4. We did last lesson. Total potential difference in a series circuit is equal to the potential difference supplied by the power supply. True. Absolutely right. So today what we are going to be looking at is we're going to be looking at the difference between AC and DC current. So, have a little read of that first paragraph there. When we plug in any device at home, it uses mains electricity. Mains electricity is called alternating current or an AC supply. An alternating current constantly changes direction, whereas a direct current or DC supply remains at the same level. So there's some annotations to add in here just to discuss our points. So, an alternating current occurs due to an alternating potential difference. That's important to know. Now, an alternating current constantly changes direction. So what we mean by that is the movement of electrons constantly going backwards and forwards, constantly changing direction. Now, a direct current, rather than mains electricity where you plug things in, it goes into an object. Direct current is often supplied by cells and batteries, where it remains at the same level because electrons are all flowing in the same direction around the circuit, because it doesn't have an alternating potential difference, it just has a direct potential difference, pushing them in one specific direction around the circuit. So pause the video, just cover over the top bit, and then see if you can have a go at, from memory, answering the definitions for alternating and direct current. Can you reproduce them from memory? Right, unpause the video and you'll see the definition for an alternating current is one that constantly changes direction at a specific frequency. A direct current is a current that has a one-directional flow. Right, so let's have a little look at this a little bit more in depth. So, the graph shows AC compared to DC. Alternating current compared to direct current. The AC is changing direction. The reason why we know that is it's going up and down and up and down and up and down. This is called a cycle. Its frequency is the number of cycles per second. In the UK, the mains frequency is 50 cycles per second or 50 hertz. Now, what we mean by number of cycles is the number of times that the flow of electrons changes direction. So when we're talking about 50 hertz, we're saying that actually the current is changing direction up to 50 times per second. Now, the potential difference is about 230 volts. So that's the voltage, the average voltage for a UK main supply, and it's the force with which those electrons are being pushed around the circuit. Now, because the AC is constantly changing direction, the potential difference is constantly changing from about 325 positive to about 325 negative volts. So what we're talking about there is positive, negative, negative, positive. It's constantly going from one to the other, whereas it's about rough average, it's about 230 volts, okay? And the same also applies for voltage in batteries, roughly about 230 volts. So that's a number. It's important to remember for the UK main supply. 230 volts is the average potential difference for it. Right, have a look at the next page, and on the next page you'll see a little video link which you'll see in the description box below. Have a pause of the video now and just make your own notes for me, please, on this video. Show our first video, video 1, which AC versus DC. What are the differences? Pause the video for me and just have a go at that now. Right, hopefully you've unpaused the video, and so you've got some notes from that video just giving you the key differences between alternating current and direct current, just summarising that for you. You will see there's a question below that says, what frequency is the voltage of the UK mains electricity supply? Now this won't be on your page anymore, might be in your notes somewhere, but hopefully you're remembering. It's 230 volts and the frequency is 50. Okay, now connecting to the mains. Electrical appliances are connected to the mains using a 3-core cable. The outer casing on cables is made from flexible plastic because this is an electrical insulator. What do we mean by the term insulator versus conductor? Can you remember? Now, an insulator is something that stops, slows flow of current, keeps it within a set place. Within the cable, there's always a blue encased copper wire, which is called the neutral wire, a brown encased copper wire called the live wire, and in some cables, usually for appliances that are metal case, there's a green-yellow cable called the earth wire. This is connected to the ground in your house so that if there's a fault in the live wire touching the metal case, the current flows to the ground through the earth and not through you if you touch it. So the job of the earth wire is safety, prevents electrocution. Prevents electrocution. Now, the wire itself is copper because this is a good electrical conductor and is flexible. Now, 2 words you might see associated with metals are malleable and ductile. Malleable means a metal can be shaped, and ductile means it can be drawn out into wires. Right. Pause the video again, and just from the text, have a go at this question for me. Just a quick 1-minute review. There are usually 3 wires in a cable connecting electrical appliances to the mains. Name these wires and state what colour they are. Pause the video, do it now, see if you can do it from memory. Right, unpause the video, and hopefully you've got written down that the live wire is brown, the neutral wire is blue, and the earth wire is green. Now, as well as wires, we also need to consider plugs. Plugs are made of stiff plastic material that's a good electrical insulator. It has 3 brass pins that fit into electrical sockets. They're made of brass because this is a good electrical conductor and it's also harder than copper. That means it's more durable. Plugs are quite hard to break, aren't they? The blue wire is connected to the neutral pin. The brown wire is connected to the live pin via a fuse. Now, you might see this before. Be familiar with this word, a fuse. You might have been at home, had a power cut. Oh no, the fuse is blown. We better replace the fuse. Now, it's basically, if you're not sure, a piece of wire that in a circuit that is incredibly thin and it melts if too much current flows through it. You've seen the symbol for it before. And if this happens, stops the flow of electricity. If it's too high, it stops the flow of electricity if it's too high. If the flow of current is too big, such as during a short circuit when the live touches the neutral, this will blow the fuse, that's the phrase we're talking about, and cut off the current. In the UK, appliances that have plastic case are said to be double insulated, so they require no earth connection. Right. Make sure you've made a little note of this, because that's an important bit of information. Pause the video if needs be. And then another thing you should do for me now is turn to your notes page and pause it. And I'd like you to draw and annotate the above plug. Because it's important for you to be able to recognise the inside of the plug from a diagram. So as you see, we've got our green and yellow cable, which is our earth wire. We've got our blue one, which is our neutral wire. And we've got our brown one, which is our live wire. Fuse, which we often find in one of these, where you place, and then obviously coated in plastic as well. So pause the video for me now, and in your own notes, if you're in revision, make sure you've made a note and annotated the above diagram. Right, once you've done that, you can unpause the video, and let's carry on. So, what I'd like you to do now for me, let's have a look back at the next page, and you'll see there's another video clip in the description below, which is just got plugs written next to it. Well, pause this video, watch that one, and try and complete the table below, just to see if you can come up with ways to remember colour and colour of the wire and where it's located. And there is a clue for each of you in each of the words here and here and also here. So watch the video. Can you come up with an idea of describing the location of each of the wires in a plug? Right, if you've watched that video and you've finished it and come back to this one, you should see that the blue wire is located on the left hand side of the plug. The brown wire is located on the right. You see what I'm doing there? Blue. Oh, wrong one even. Excuse me. Blue, left, brown, white. And then the yellow and green, where's it located? The slash is in the middle. These are where the wires are located in the plug. Right, let's carry on just looking at the paragraph below then. The live wire carries the current and is at a potential difference of about 230 volts. Remember, as we said, this is average for the UK. The neutral wire is at or close to earth potential of 0 volts. The earth wire is 0 volts, and it only carries a current if there is a fault. Remember, we said it's a safety feature. The live wire is always dangerous, even when the appliance is switched off. If a person touches this wire, they will provide a pathway for current to flow and get an electrical shock. There are also danger if the earth wire touches the live wires. The earth wire is in your house become live. So remember, if you touch something electrical, you provide a pathway for it to go down because you are an electrical conductor. And that's partly to do with the large proportion of water in your body, because that also conducts electricity. That's partly why humans are really good at conducting electricity, so don't touch an electric fence. And if we carry on, it's preventing this for appliances to have plastic casing, double insulated in plugs, so the earth wire isn't necessary. So just pause the video now and have a little look at the quick checkpoint question for me. For metal appliances, where is the earth wire located and why? So it's connected to the metal casing of the appliance. If the live wire becomes loose and touches the casing, current will flow through the earth wire, preventing electrocution. It's a safety feature. Good. Right. Now, can you have a go for me now at the following two pages, page 38 and 39, exam questions looking at plugs and the details alongside them for me. Just zoom that back in for you. So, pause the video and have a go at the questions on the next 2 pages, seeing if you can apply what it is that we have done. Right, hopefully you've had a go at those exam questions and you've unpaused the video, and we can just have a look at some of those answers. Right, so figure 1 shows a radio. The radio can be powered by connecting the 2 core cable wires to the mains electricity supply. What must be fitted to the cable before it can be connected to the mains electricity supply? Plastic casing to insulate the flow of electricity. There are only 2 wires inside the cable. What are the names of the 2 wires inside the cable? What are the ones that are going to be useful? It's out of our 3 wires. Is it live, neutral, and earth? So it's 2 of those 3. So the live and neutral wires, correct if you didn't quite get it right. Now, what's the phrase? It's safe to connect the radio to the mains electricity supply using a 2 core cable because the radio is what insulated? What phrase have we used so far? Double insulated. Figure 1 shows the inside of a 3-pin plug and the length of a 3-core cable. The cable is connected to the plug. Complete the table to show which plug terminal A, B or C connects to each of the wires inside. So remember, left, right, middle. So the live wire is A, B or C. C. So remember, live wires on the right. Neutral, A. It's on the left. And then earth, obviously, should be able to figure that one out, is B in the middle. Name a material that could be used to make the case of the plug. Case has got to be insulated, and that means made out of plastic. Sometimes see them made out of maybe rubber, but good insulators, but they're less common. Plastic is our common factor here. And then in a mains cable, which wire goes alternatively positive and negative? It's a safety wire. Is or at close to 0 volts. It is dangerous even when the main switch is on. So constantly changing because it's got current flowing through it. It's the live wire. Is a safety wire. Which one's for the use for safety? Earth, good. Which one is close to 0 volts? Neutral. Remember, neutral often means 0. And then it's dangerous even when the mains is switched on or main switch is open. Live wire. Why should the switch always be on the live wire rather than the neutral wire? What answers did you put? Have a look at this and see if it matches up. A switch in the electrical circuit is always connected to the live wire so that the socket appliance is not live when it's switched off. If it was in the neutral wire, the socket and appliance could still become live in the event of a short circuit as it's connected to the live wire. So that main idea is safety. And then which wire is only used if there's a fault in the circuit? But it's the earth wire because it takes current down into the ground rather than into someone or into an object if it overloads. Okay. Have a little look for me now at, let's just zoom out and find it. A bit further up. Have a little look for me now at this exam question. Use what it is you know. Write out the question on your notes page or in your notes book. See if you can get them right, and then we'll go through the answers in a moment. Right, you should have had a go at this and unpause the video. So if you've had a go at this, mark your answers for me now. You'll see. For number 1, matching. The potential difference of the mains electricity supply is about 230 volts. The frequency of mains electricity in the UK is about 50 hertz. The mains supply in the UK produces a current that is alternating. So the potential difference between the live and earth or neutral, okay? Could be either. The potential difference is between the earth and neutral wires. is 0 volts. Doesn't matter which order they come in. When an appliance is connected to the mains and turned on, a current flows in the live and neutral wires. Describe the reason for having an earth wire in a circuit. Safety. Safety. It conducts current safely to the earth if there is a fault. Good. So if you had a go at that, now what I'd like to do is just move on to our last set of questions to begin with, of just summarising this content. Pause the video and have a go at these knowledge and application questions based on what it is that we've done today. Right, hopefully you've had a go. Unpause the video. Let's see how well you've done. Mains UK voltage, 230 volts. Identify the UK AC supply frequency. It's about 50. Hopefully you've drawn the shapes of the graphs, looking a bit like that. Colour of the live wire, brown. Colour of the neutral, blue. Yellow and green for the earth wire. Which wire is most dangerous? Live. Which one normally carries no current? Earth. Only carries it in emergencies or if there's a fault. And which wire has a voltage close to 0? Neutral. Then just think back to energy. I've not done it for a little while. Can you remember any of these? Name an energy store. Could have had any of these. And name an energy pathway. Could have had any of these. Mark your work. See how many you got. Correct anything that you got wrong. And then the last thing I'd like to do, just on your notes page, your notebook or anything like that, is have a look for me now at these questions. Pause the video. Use your notes. How many can you do? Pause the video, see how many you can have a go at using revision guides, websites, your notes from today's lesson, and then I'll give you the answers in a moment. Right, if you've unpaused the video because you've had a go at these questions and you've worked your way through as many as you can, you'll see the answers now are on the page below. So, questions, standing still, questions 1 through to 19. Mark them and correct them where you see fit, where you need to, and then you'll see at the very end of this lesson, if there's anything that you struggled with, have a look at the lesson summary videos that are down in the description, make your own notes, just go